The Framework Desktop is the newest machine to land with AMD's Ryzen Max Plus 395 chip that has 128 gigs of RAM, which is fantastic for local AI like large language models and image and video generation. And while they're a little late to the party, not the first, not the second, not even the third, they might have just nailed the best cooling solution yet. I've tested the Asus Flow Z13, impressive for cramming this chip into this laptop, and the gmktec Evo X2, a tiny powerhouse, gets a little noisy, but capable. But the framework board? Wow. Whisper quiet. Think Mac Studio level quiet. Speaking of Mac Studios, I've been testing some clusters on this channel. I did a Mac Studio video, I did a Mac Mini cluster video. You might have seen those. I thought it would be fun to stack 4 Framework desktop boards, just like the ones they showed off earlier this year when they announced the Framework Desktop. And while this is great, I think we can improve a few things. And we're ready for our first race. Here I've loaded up Qwen 3 Coder 30 billion parameter model at Q8. Q8 is the quantization. That means the model is quantized down to 8 bits from the original so that it could fit on smaller hardware like we have here. And this model is about 30 gigs in size. This is a medium-sized programming architecture prompt. Design a scalable web application architecture for an e-commerce platform. Let's go. And off they go. This is a pretty long response. Now, why am I racing the same LLM on 4 identical Framework desktop boards? Because memory is king for local AI. And this AMD chip lets me flip between 2 GPU memory modes in the BIOS. There's dynamic, where the CPU and GPU borrow RAM on the fly, or fixed, where the GPU gets a permanent chunk. This is unlike Apple's always shared UMA, or Unified Memory Architecture. This split could mean the difference between smooth, sustained performance and unexpected slowdowns. And this is something that's often confusing with the new RAM settings that I wanted to clear up right away. We got slightly different results, but within the margin of error here: 37 tokens per second, 42, 43, and 37. Now, I've tested different settings before when I was testing this machine, and I got different results. And in that video, I concluded that the auto setting in Windows is not the best option. But here we're on Linux, and when I did some testing using a bunch of different prompts from 17,000 tokens to 45,000 tokens, all the way down to 100 tokens, and these range from code-heavy programming prompts to architecture prompts, non-programming explanations, and so on. Even a simple hello greeting is in there as well. I wrote this test and I automated the process of running these many times over so we get some statistically significant data. By the way, here this machine is set to 64 fixed, this one is set to 16 fixed, this one's set to 96 fixed, and this one is dynamic, set to 512 megabytes. You can tell the difference here in the kind of prompt you issue and the size of the prompt too. This also matters what kind of model you're running, so there's a lot of variation. So for this particular model, Qwen 3 Coder 30B with Q8 quantization, the dynamic setting in the BIOS actually is faster for a lot of these. For example, this medium architecture prompt, we got 42 tokens per second for the dynamic setting, and the next lowest down was 41 for the 96 fixed setting. The worst one was 64 gigabytes. You can see that yellow bar sticking up on most of these, except for when you get to really large prompts. Right down here, the 96 gigabyte setting wins out here. 19 tokens per second for the 17,000 token prompt, and for the 45,000 token prompt, we got 10 tokens per second. I just want to pause right here and say, this is running on the iGPU, the integrated GPU. It's not one of these, folks. It's inside. Now, we've seen this, of course, from Apple, but we haven't seen such performance on an iGPU until this chip. And since we're talking about memory, bandwidth matters just as much as capacity. This is how the chip's bandwidth stacks up against the competition. Here's Ryzen AI Max Plus 395 at 256 gigabytes per second. Not bad for an iGPU. We've got Apple M4, which is lower, Apple M4 Pro, which is higher, and then of course M4 Max and M4 Ultra have pretty high memory bandwidths, and it shows. I'm gonna show you some charts in a bit. Then we have this one, NVIDIA DGX Spark. Still waiting for that one. Where is it? But also keep in mind that this is the only machine on this list that's x86. So it's gonna run all your Windows and all your Linux. Is Linuxi? In other words, it's gonna be super compatible with pretty much everything going forward and legacy. Speaking of Apple's M4 Pro, I ran the same model with int8 quantization, and yeah, it is a bit faster than this desktop. For example, this short programming prompt, 47 tokens per second for the framework and 55 tokens per second for the M4 Pro. But that's for all these prompts. The really short prompts, the framework desktop wins. But of course, who's happy with the really short prompts? For the extra long prompt, the framework desktop won again. It beat out the M4 Pro, which is not a small feat. Another advantage of the framework desktop is 128 gigs of RAM, whereas the M4 Pro is capped at 64 gigabytes, and that's only on the Mac Mini. Very expensive little Mac Mini. Now, if you want to go to 128 gigabytes in the Mac world, then you have to get either a MacBook Pro with 128 gigs, the M4 Max, or the M4 Max Mac Studio. That's not this one, but it looks just like it, okay? Prop. Nope, not the $2,000 one, because that's limited to 36 gigs of memory. Oh yes, Apple will get ya. You gotta go to this one, and then you have the 128 gigabyte option for $1,000 more, and then you're at 3,500 bucks. But wait, let's also get the same terabyte drive that I have in those framework desktops. Now you're at $36.99. Yeah. But to finish that thought, here's the comparison. Yeah, the M4 Max is significantly faster due to the memory capacity, the memory bus width, and that relates to memory bandwidth. It beats out the framework desktop in all the tests. So these days, I'm constantly flipping between models. GPT-4o for notes and email, Claude for code refactors, Flux for image generation, Kling for video, 4 tabs, 4 bills, and counting. Enter ChatLLM Teams. There's one dashboard that houses every top LLM, and ROCm picks the right one for you for a given task. O4 Mini High for fast answers, Claude Sonnet 3.7 for coding, Gemini 2.5 Pro for big context, and even adds GPT 4.1 before ChatGPT has it. Chat with PDFs and PowerPoints, then generate decks and docs and do deep research all in the same chat. Need human-sounding copy? The Humanize toggle rewrites text to beat AI detectors. Spin up agents and run code with AI Engineer. I built my first bot in just minutes. Track artifacts, create GitHub pull requests, and debug from the same interface. Need visuals? No problem. Use Flux or Ideogram and Recraft for images, Kling, Luma, and Runway for video, all built in. And the kicker is just $10 a month, less than one premium model. Head over to chatlllm.abacus.ai or click the link in the description and level up with ChatLLM Teams. So there's the GPU part of the story, which we'll get back to in a moment, but there's also that CPU. It's 16 cores, 32 threads. Let me ask you a question. Can you hear anything right now? There's 4 of them running, all on top of each other in this rack. I'll tell you what I can hear. I can hear that switch. Yep. But I can't hear any of those framework desktop boards. And this is what shocked me the most. All right. I'm getting back into that. I can't get distracted. Let's talk about that CPU, which is a powerhouse. Just a little detour, okay? Because I just saw this tweet by DHH. He says, the framework desktop AMD 395 is putting out a measly 17,000 multi-core Geekbench score in the Verge and Ars Technica reviews. But he got 3,100 single-core score and 25,474 multi-core score. So I was like, what? How is that even possible? I mean, it's possible, obviously, but I had to dig things up. So here is the Flow Z13 score, 20,000. The M4 chip has a multi-core score of 15,000. The M4 Pro, 20,000. Okay, it's about there. Here's the M4 Max, 25,900. That's crazy that the CPU score is about the same as the M4 Max. Now, I ran this myself, of course. I got just over 23,000, but this was on Fedora and DHH was using Arch Linux. Maybe that has something to do with it, I don't know, but that's still pretty high. And I got that score on both the framework desktop and on the Evo X2. That chip's good. As a side note, this is my first time using Fedora, and I've got to say I'm really liking it more than Ubuntu. Stuff just works. Well, mostly. ROCm install on bare metal was still rocky, which is why I ended up using Donato Capitala's toolbox images to quickly swap between Vulkan, ROCm, and even different ROCm versions without reinstalling the whole stack. The other way you can try out ROCm and Vulkan is in LM Studio. As a side note, if you don't know what I'm talking about, you want your LLMs to run fast, you want them to run on the GPU instead of the CPU, you have to provide that API to do parallel programming, and there's many different approaches to it. The two most popular for AMD are ROCm and Vulkan, and LM Studio detects this and installs these automatically, which is kind of cool. So you can run your LLMs on ROCm, you can run it on CPU, or you can run it on Vulkan, and they all use Llama CPP as the backend, which is a popular backend to use for inference. Ollama also uses it, but Ollama at this time doesn't really use Vulkan or ROCm. I couldn't get it to work, so it uses the CPU, which in turn becomes really slow. Now I have Vulkan selected for LM Studio because I found that it is the fastest. In fact, there are certain models that wouldn't even load under ROCm at all in LM Studio. The really huge Qwen 3 235 billion parameter model, which is 103 gigabytes on disk. Believe it or not, that loads on one of these. I mean, why would you not believe me? I'm doing it right now. And there it is. It's loaded. I can start querying it. Boom. Not bad, right? Well, it runs under Vulkan, but it does not run under ROCm. I'm getting 9 tokens per second there. One weird quirk that I found after I started testing the new GPT open source models by OpenAI, and those models are much smaller than this dense model, or even the Llama 3.370 billion instruct dense model, which load fine on all these, and they are chunky, 40 gigabyte model that wouldn't load on any of the NVIDIA GPUs that I have, unless it's the RTX Pro 6000. I did a video on that one. That one's got 96 gigabytes of VRAM. But yeah, even this 11 gigabyte GPT OSS 20 billion parameter model loads fine, and it works pretty fast, 63 tokens per second for a short prompt like that. But for some weird reason, trying to increase the context length to something a little bit more useful than 4,000 tokens, and the whole model crashes. Now I found that this model with the extra long repo analysis prompt also doesn't work on the GMK Evo X2, even though they have both 128 gigabytes of VRAM available, so it crashes there. And this, by the way, is a mixture of experts models, so it doesn't use all the active parameters all at once, taking up a lot less space and running much faster when you're doing inference. So why wouldn't it load? That's a mystery. However, the 17,000 token prompt did load on the GMK Evo X2, but did not load on the Framework desktop. You might notice something else from this chart is that the Evo X2 is beating the Framework desktop in pretty much every single instance of every single LLM run. Here is the 120 billion parameter model, GPT OSS 120, same thing. The Evo X2 beats out the Framework in pretty much every case. Now I had to test these out because they're so new. What about the ones we've been waiting for, the Qwen 3 coder? I'm gonna pick the fastest result here for Framework, which was the 96 gigabyte fixed version. Like I said before, it depends what model you're running, what memory configuration works best for that. And here we are going up against the M3 Ultra by Apple, the M4 Max, the M4 Pro. The M4 Max is really doing quite well, better than the M3 Ultra, which was surprising. But also keep in mind that those are MLX models running on Apple, which are optimized for Apple Silicon. These are just running the standard GGUF models, and I'd say they're doing pretty well. Here is the short programming prompt, 65 tokens per second. By the way, these are all on my GitHub, so if you want to check out the actual prompts, I'll link to it down below. Here's the long architecture prompt, 52 tokens per second. Wow. Let's take a look at the gmktec Evo X2 here as well, and you'll see that they're actually really close. 45, 45. Where they stray a little bit is on the longer prompts. I'd say the long to medium prompts, the gmktec box actually wins a little bit. And these are not just one run. These are multiple runs, multiple iterations, just to get a statistical analysis here, until you get to the really long prompts where the framework desktop actually beats out the gmktec Evo X2. And that might have something to do with framework's cooling. It keeps it whisper quiet, on par with Mac Studio, like I mentioned earlier. I'm just really impressed with it. That's why I keep talking about it. I've built a bunch of LLM geared PCs that I've started reviewing on the channel here, and this has been the easiest machine that I've ever built, and also the quietest. So as I mentioned before, Vulkan is your best bet right now on these chips. Here's why. I'm going to use Donato's toolbox, and you can just say toolbox list. It'll give you what I have installed on there. Here I'm going to use ROCm. Over here on this one, I'm using Vulkan, and over here I'm using Vulkan, but there are two different versions of Vulkan. I didn't know that until I saw his video, which I'll link down below, by the way. Nice channel and good video. His toolbox already has Llama CPP installed, so you can run inference against models, and it's using the GPU on all these. So here it is running with ROCm, and I'm doing Llama Bench here so I can get the token generation time and the prompt processing time for this particular model on this chip. And here we go. GPT OSS, this is the 20 billion parameter version. We've got 566 tokens per second, PP512, which means prompt processing, and TG128 is token generation, 62. Not bad, right? Let's go over to Vulkan over here. Running the same thing again, and I'm gonna run the same thing on this one too. Yeah, interesting difference, huh? So for this one, we've got token generation 70. Much higher than ROCm. And this Vulkan also gives us 71, which is pretty close to 70, so they're about the same. But look at the prompt processing speed. Here we've got 575, and over here we've got 1163. Much faster. What's the difference between those two Vulkans? And this is where I would insert a Star Trek joke, but I don't have anything right now. Put one down below if you think of something. Well, this one is RADV, which is a community developed version of Vulkan. And this one is AMD open source driver, which is developed by AMD themselves. Now, this is just an example for this particular model and the differences that it has. New version of LLM Studio, always a new version whenever I open it. I'm gonna go to LLM Studio and say write a paragraph over here, and I'm getting 63 tokens per second, which is slower than both Vulkans over here. It's closer to what ROCm is giving us for this particular model, yet I do have Vulkan selected for my runtime. It doesn't say which version of Vulkan this is using, and I was gonna try and guess, but now I can't because the number is much lower than I'm getting with Llama CPP directly. Now let's try the most dense model that I have, which is Llama 3.3 70 billion. I just want to come back to this for a second. These are now running. They're running on the GPU. If we take a look at the GPU, you can see what's going on right there. That's pretty crazy. Oh, I've just started hearing the fan, but that's like just now, after all this, I've just started hearing the fan, and it's still not ridiculously loud. So props to Framework for getting a machine like this done. Oh, this one's taking a while. You can imagine that this is pretty much what it's doing right now on those other three machines. Here I've got Llama 3.370 billion parameter model pulled up in LLM Studio, and it is pretty slow. It's going at 4.94 tokens per second. Let's see what we get with Llama Bench directly. We got some results for Vulkan, both of them, 72 tokens per second prompt processing and 5 tokens per second token generation. Here also 5 token generation, 46 prompt processing, but the ROCm implementation is not going anywhere. In fact, this is something that Donato mentioned in his video. He said that for some of these models, it could take forever to load using ROCm unless you use a special flag called NoMap. Well, apparently Llama CLI has that flag, but Llama Bench doesn't. So we're kind of stuck. That's where ROCm is right now, folks. Hopefully it keeps getting worked on and improved, but it's nice to have a couple of different options. Now I want to get back to the question of the board itself. This is Framework after all. Those are the people that, you know, give you laptops. You can change the board out, you can change the cards out, the ports, the RAM, and you can't change the RAM on this. You can pretty much do everything else. You can put your own fan on, you can put your own power supply, but the RAM is soldered onto the board. It's part of that whole APU package for that Ryzen chip that's inside. Isn't that against what Framework stands for? Here's Nirav, the CEO of Framework, on Linus Tech Tips just a few months ago.
So we did actually ask AMD about this. The first time they told us about Strix.io was actually literally our first question. How do we get modular memory? We are Framework after all. And
the other guy is Linus, by the way.
And they didn't say no, actually. They did assign one of their technical architects to like really go deep on this. They ran simulations, they ran studies, and they just determined that it's not possible with Strix.io to do LPCAM. The signal integrity doesn't work out because of how that memory is fanning out over the 256-bit bus.
Oh, well, that's bad news.
Now, Linus has to say that because of his core audience, of course, but he knows his investment in Framework will pay off big time. Apple has had unbelievable success with soldered RAM, and the numbers, both the bottom line of the company and the benchmarks, don't lie. Yes, this is good for business because it's going to give them better products, but it's also good for us. Some may argue that, and feel free to do that in the comments below, but I think that performance is king in my world, and I would rather have a machine that performs faster doing these kinds of workloads and developer-related workloads than having the ability to change the RAM out. Amazing transparency on Framework's part though. So yeah, technically it's a trade-off, but I think it's the right one. The rest of the system still keeps Framework's ethos intact. I didn't even get the full desktop, I just got the boards, and that means I could pick my own case, my own fan, build it my way. There's 2 SSD slots. You can use whatever SSDs you want. By the way, the SSD that Framework sent me along with all this is the Western Digital variety, and the speed is incredible. It lives up to its label. In my opinion, the board is actually a good buy because I don't need the modular connections that come with the case that comes with the desktop. The board gives me everything I need. It's got 2 display ports and 1 HDMI, so a total of 3 connections directly to a monitor, and 2 USB 4 connections right on the back, along with 2 USB-A connections. The board also has expansion that you can plug in more USBs if you need that in your own case. I demonstrated how easy it was to put this thing together and even swap out the SSDs in a live stream recently. Check that out if you missed it. If you don't need their modular desktop chassis, you can save a lot with a budget case and still keep things whisper quiet. But I haven't set up the cluster after being a little bit discouraged when I saw Jeff Geerling's video and he got only 0.7 tokens per second, which is completely unusable. But I think there's still opportunity here. You saw me running the 235 billion parameter model that takes up 111 gigabytes while it's running on one of these. Now you could use 2 of them and run a slightly bigger model, but the more nodes you add to a cluster, the slower it's gonna get because you're bottlenecked by network. I have a 10 gigabit switch here, so these are getting nice fast Ethernet, but even after connecting these together using USB 4, it's limited by the network manager in Linux, which caps it at 10 gigabit also. So you're not getting the full speed that you can through Thunderbolt 4 here, and therefore you're not going to be able to run the huge DeepSeek or even Qwen 3 Coder 480 billion parameter models by throwing more nodes at it. Bigger models? Yes. Faster? Definitely no. I'd stick to running one of these at a time as it's a pretty good machine on its own. But definitely check out Jeff's video as he goes into more detail on his cluster setup. And if you want to see my Mac Mini cluster setup, watch that video over here, or my Mac Studio cluster setup, watch this video over here. Thanks for watching, and I'll see you in the next one.